So today we're talking about section 1.7, which is inverse relations and functions. So you already learned how to find inverses in Algebra 2 with trig, but we're going to remind you how to do it and then look at a couple different problems that you haven't seen before. So go ahead and start with the opener here. Find two functions f and g such that f of g of x is the square root of x squared plus 2. Go ahead and try that out. All right, so there's a couple of possible different ways of doing this. I don't know why I paused so long when you probably paused the video, but I know that whatever, I have to take g of x and plug it into f of x. So what I can do is I can call this g of x, x squared plus 2, and then I was plugging it into f of x, which would have to be the square root of x. So now if I substitute this into this, I get this, right? It's not the only answer, but it's the first one I thought of. Okay, so let's move on to what we're talking about today. So example 1 says let f of x be equal to x squared minus 1. So first off, let's make a table of values for f of x. So you can go ahead and do that on your own. I will say that the easiest way to do this is start by putting your vertex right in the middle right here. So that's an upward facing parabola. The vertex is 0, -1, and then you can plug in 1 and 2 and reflect -1 and -2. All right, 1 squared is 1, 1 minus 1 is 0, 2 squared is 4, 4 minus 1 is 3. And then I'm going to get the same thing here and here because it is symmetric and I found my vertex first. But if you check by plugging in -1 and 2, you can see that it's right. Okay, so in pink here, I'm going to graph this parabola. 0, -1, 1, 0, -1, 0, 2, 3, and -2, 3. And there's my parabola. Okay. Next, it says B, make a table of values for f inverse, which is, sorry, f to the little -1 just means f inverse. Graph with a different color. So let's switch colors here. I'll do green. Now remember, if I asked you to find the inverse of a function, what would be the first step? Hopefully you're saying switch x and y. So what I can do here is just switch all my x values and y values. So my first point that I'll graph is 3, -2, followed by 0, -1, -1, 0, 0, 1, and 3, 2. So all I did was switch the x and y values in that first table there. Now I'm going to graph these points. 3, -2, 0, -1, -1, 0, 0, 1, and 3, 2. Connect those points, make your parabola. And there is my sideways facing parabola. Okay, now let's move on to C, which says graph y equals x. So please realize, I'm going to do this in blue here, that this is y equals 1x plus 0. All right, so y equals x is the line y equals 1x plus 0. So y-intercept is 0 and then a slope of 1. I'm graphing it with a dashed line because I want you to see what's happening here. Oh, it does say dashed line anyways. It says dash, so that's why I'm doing it. Okay, so it says is f of x, so is the pink one a function? Yes, passes the vertical line test. What about f inverse? No, it doesn't pass the vertical line test. So what could I have done without ever graphing the green function to figure out that it is not a function? Sorry, I could just call it a function. The green sideways facing parabola, how could I have figured out that that was not a function before I even graphed it? The answer is the horizontal line test. So if I rewound, got rid of this, got rid of the green. Oh, I didn't want to do that. But I got rid of these green points. I'm not going to erase all those because that happens. If I would have just checked this and said, is this a function? Yes, it passes the vertical line test. Is its inverse a function? No, because it doesn't pass the horizontal line test. So the horizontal line test tells us if a function's inverse is a function itself. Also, what I want you to notice about this green line right here is that, the y equals x line, all three of those graphs intersect at that point there. So if you look, let me change colors here, what I'm talking about. Like they all intersect right here, and they all intersect right here. Okay, and then they're reflections of each other. Like there's a point here, there's a point here, there's a point here, there's a point here, 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 here. So it is a reflection over that line. Oops. Okay. So this says, will the inverse be a function for each graph? So first off, let's go through and make sure we understand. Looking at this, is A a function? No. Is B a function? Is A a function? Yes. Is B a function? Yes. Is C a function? Yes. They all pass the vertical line test. So now let's answer the actual question is the inverse a function? So we're checking for the inverse, whether it's a function. So to do that, we're going to use the horizontal line test. Fails. So no, the inverse is not a function. Yes, the inverse is a function. Yes, the inverse is a function. So it says if a function passes the horizontal line test, then it's said to be 1-to-1. So that's vocabulary that you need to know. So basically, if a graph passes the vertical and horizontal line test, it's 1-to-1. This means no x value is matched with more than one y value, and no y value is matched with more than one x value. This also means a graph will pass both vertical and horizontal line tests. Which graphs above are 1-to-1? B is and C. Okay, let's move on to finding the inverse of a function. So first things first, we changed the directions on this. It's determine whether the inverse is a function, then find the inverse. We are not stating any restrictions on the domain. We left it in the notes like that because the homework in the book says the same thing, and find restrictions on the domain, which you don't have to do. Okay, and I didn't assign you that bookwork, but if you would like to try some problems, that's what the directions are going to say. Okay, so we are determining whether the inverse is a function, and then we're also finding the inverse of it, no matter what, even if it's a no. Okay, so let's start with this. I want to know, first off, is the inverse a function? So in order to know if the inverse is a function, I have to know what this looks like. This is a positive slope line. It looks like this. So does it pass the horizontal line test? Yes, the inverse is a function. So now we are going to find the inverse. So this is super easy. This is basic here. So step number 1 is switch x and y. X equals 2y minus 6. Remember, this is just a fancy way of saying y. Now you are going to solve for y. So add 6 to both sides. X plus 6 equals 2y. And then finally, to get y by itself, you're going to divide both sides by 2. Divide by 2. So we are not going to write y equals because it was not y in the first place. It's the inverse of f. So we're going to write f inverse equals. You can either leave your answer as y plus 6 divided by 2, which I'm fine with. But I need you to know that it's equivalent to if you divide this by 2 and divide this by 2. So f inverse of x is equal to 1/2 x plus 3. And that's more like what we're used to seeing, an equation of a line in slope-intercept form. So either one's fine for your final answer, but just you have to know that they're equivalent. All right, this one, first off, I want to know, is the inverse a function? So first off, think of what this looks like. It's upward facing parabola. So does it pass the horizontal line test? No. The inverse is not a function. That doesn't mean I can't find the inverse. We're still going to find it. So we are going to switch x and y. X equals y squared minus 2. And now I'm going to solve for y. So first off, I'll add 2 to both sides. X plus 2 is equal to y squared. And now I need to solve for y by square rooting. So remember, whenever you put a square root in, you have to do plus or minus because you have to account for the positive and negative answers. So I have f inverse of x is equal to, and then it's plus or minus the square root of x plus 2. Now I didn't write down plus or minus at first because I want you to realize that if you forget it, what you're forgetting. Think about if I asked you to graph this, what does it look like? If I asked you to graph this, what does it look like? It looks like this, right? So if you forget the plus or minus, you're only accounting for this piece. Now realize this has 2 pieces. It has this and this. So you have to account for that part, the negative parts. That's why it's plus or minus. Just a little extra info there. Okay. Next 2, same directions. We're not stating any restrictions on the domain. All right, this is a square root function. It looks like this. Does it pass the horizontal line test? Yes. So now we're going to find the inverse. This is a yes. We have x equals the square root of y plus 2. Solve for y. Subtract 2 from both sides. And now I'm going to square both sides to get rid of that square. So I have f inverse of x is equal to, and then I have x minus 2 squared. So I'm going to go ahead and expand that. On your test, it will say, if there's a problem like this, it'll say expand any answers. So x squared, x minus 2 times x minus 2 is x squared minus 4x plus 4. Now you might be thinking, back to the last one, saying, hey, that's a parabola. If I'm finding the inverse, I only want part of it. There's restrictions on it, and that's what this asks us to find. We're not having you find the restrictions, so we're just going to say that no, that it's only part of that though. Okay, so next one, we have a reciprocal function. We know what a reciprocal function looks like. It looks like this. There's a vertical and a horizontal asymptote, but it passes the horizontal line test. So yes, the inverse is a function. So this is the only type of problem that you did not find the inverse of in Algebra 2 with trig. So pay close attention so that you can see the steps. All right, switch x and y. All right, now you have to get y by itself. So what you should first off notice is that you have y's on the right-hand side of your equation, both in the numerator and the denominator. So you have multiple y's. So here are your steps to getting y by itself. The first thing you're going to want to do is that you're going to want to expand this. In order to do that, you're going to want to cross multiply. So I'm going to cross multiply. I have 1 times y plus 2, which is y plus 2, equals x times y minus 4. Should probably make my 4's look more like 4's. There we go. All right. So right now I still can't get y by itself. So what I'm going to do is I'm going to expand this even more. So I said I was going to expand it by cross multiplying, but I never actually multiplied, right? I still have to do that. I have to multiply these. So now I have y plus 2 equals x times y is xy. X times negative 4 is negative 4x. Okay, so now I have to try to get all my y's on one side of the equation. So everything that has a y in it is going to go on one side. Everything without a y is going to go on the other side. So I'm going to put everything with a y on it on the left-hand side of the equation. So I'm going to subtract xy, subtract xy. Now I have on the left-hand side y plus 2 minus xy. But I don't want that 2 over there, so I'm going to get rid of the 2 and move it onto this side. So now I have y minus xy equals negative 4x minus 2. All right, I'm getting closer to getting y by itself, but now that I notice that it's on the left side, but there's a y stuck in each of my terms. So I have to get it out of being stuck in each of my terms. So I'm going to factor it out. I'm going to factor a y out of each of these terms here. So when I do that, I'm left with 1 minus x equals negative 4x minus 2. So now I'm on my last step to getting y by itself. Remember, this is implying multiplication, so I'm going to divide by 1 minus x. And I have f inverse of x is equal to negative 4x minus 2 over 1 minus x. All right, when checking your answers on these, it's really important that you know that equivalencies. What I mean by that is that when we're working with numbers, if I tell you the answer is 1, and that's because 1 divided by 1 is 1, realize you also know that negative 1 divided by negative 1 is 1. Both of these are equal to 1. But we would simplify both to 1. What's more simplified, this or something that looks similar that's not simplified? So I want you to realize when you have the exact opposite of this answer, so the opposite of negative 4x is positive 4x. The opposite of negative 2 is positive 2. The opposite of 1 is negative 1. The opposite of x, negative x, is positive x. This answer is the same as that answer over there. So when you are checking your answers, please make sure you're keeping that in mind. Okay, so what I'm going to do is at the end of notes, I'm going to make up a problem exactly like that and do another one just in case you're like, what just happened? Okay, so last topic for today is show using compositions that f of x equals 2x plus 4 and g of x equals 1/2 x minus 2 are inverses. So really important right here. Two functions, f and g, are inverses if and only if f of g of x is equal to g of f of x. Now, we learned yesterday that both of them will simplify to x if they're inverses. Knowing that, as I think is not so great because then people just automatically don't show their steps. Make sure you show your steps, okay? So what I'm going to do is if it says show using compositions, that they're inverses, I'm going to find f of g of x, and I'm going to find g of f of x, and I'm going to simplify both. All right, so let's start with f of g of x. So I'm going to take f, and I'm going to plug in g of x, which is 1/2 x minus 2. All right, here we go. I have 2 times and then 1/2 x minus 2 plus 4. So you have to show your steps here. So first thing I'm going to do is distribute. Distribute, right? And I get 2 times 1/2 x is x. 2 times negative 2 is negative 4, and then plus 4. And then you can see that these cancel, and this simplifies to just x. All right, now let's do g of f of x. So I'm going to take g, I'm going to plug in f of x, which is 2x plus 4. All right, so now I'm going to plug that into g, so 1/2 times 2x plus 4 minus 2. So once again, what you can't do is you can't go equals x. Like, it's going to equal x, but you have to show in steps that it's equal to x. So here we go. I'm going to distribute my 1/2. 1/2 times 2x is x. 1/2 times 4 is 2. And then minus 2. So I get the 2's cancel here, and I get just x. So notice these steps will never match right here, so we do look for those separate steps. Okay, so check, check. They're inverses. Okay, and also the directions say show using compositions that they are inverses. So we're already telling you that they are. You just have to show the algebra that says that they are. All right, I left the easiest problem for last, and then I'm going to do another one like this one right here in case you want to see it again. If you don't, then you'll be good for the day. Okay, so use the graph of f of x to graph f inverse. Is f of x 1 to 1? So first off, we can answer that already. Is the function 1 to 1? No, because it doesn't pass the horizontal line test. So no. Oopsies. Now I'm going to graph f inverse of x. So I'm going to use points to help me. I'll start with this point, and then I'll graph the inverse of it. So I'll switch x and y. So that point is -5, +6. So that means 6, -5 is on this graph. Now I'm going to graph this point right here. It's a little off, but we tried really hard. That's -3, 3. So now I'm going to graph 3, -3. And then I'm going to immediately connect those because those are connected together. Next, that point right there, I can see 3, 5. That means 5, 3 is on my graph. And then once again, I'm going to immediately connect those two. And then last but not least, 4, 0, 0, 4, immediately connect. And there's its inverse. One thing that I want to point out is that I immediately connect for a reason because I've seen people make the points first and then connect them incorrectly. They'll go like here, then here or something. You know what I mean? Okay, so if you are solid with this problem right here, then you can go ahead and start working on the review for the test. If you're not, let's look at one more. I'm just going to make one up. So I'll say my function is f of x equals 3x plus 5 over x minus 2. Randomly made up, right? Okay, so if I wanted to find the inverse of this, step number 1, once again, is switch x and y. X equals 3y plus 5 over y minus 2. Now you're going to cross multiply to start to expand this. 1 times 3y plus 5 is 3y plus 5. Then I have x times y minus 2, and I need to distribute that. So if you skip this step right here and automatically distribute, great. X, y minus 2x. All right, the next step is to get everything with a y in it on one side of the equation, everything without a y on the other. So I'm going to get everything with y in it on the left side of the equation. So I'm going to subtract xy, gone off that side. But now I have to get the 5 off this side. -5, -5, gone off this side. So now I have 3y minus xy equals -2x minus 5. All right, remember you're almost there, but the y is stuck in those two terms. So now I'm going to factor the y out of those terms. I have 3 minus x equals -2x minus 5. And finally, I'm going to divide both sides by 3 minus x to get y by itself. So now I have f inverse of x is equal to -2x minus 5 over 3 minus x. Okay, so hopefully that was like, oh, okay, yeah, I got it. All right, you can go ahead and get